Look around you. There's probably a glass of water somewhere nearby. You've seen rivers, lakes, rain, the ocean. Water has been part of every single day of your life. But have you ever stopped to ask, why can you see through it? Why isn't water green like leaves, brown like wood, or black like stone? Imagine waking up tomorrow, and suddenly every drop of water had turned completely white. You couldn't see the fish beneath a lake. Swimming pools would become giant bowls of milk. Even drinking a simple glass of water would feel completely different. So, why did nature make water transparent? When we say water is transparent, we're actually saying something slightly wrong. Water isn't invisible. It does have a color. In fact, if you've ever looked at an enormous glacier, or stared deep into the middle of the ocean, you may have noticed something strange. Water looks blue. So why doesn't it look blue inside your drinking glass? The answer lies in something that's traveling around you every second. Light. Every object you see exists because light reaches your eyes. Imagine sunlight as billions of tiny travelers. Every second, they crash into everything around you. Some objects absorb those travelers. Others reflect them. A ripe tomato reflects mostly red light. Leaves reflect green. Charcoal absorbs almost everything. That's why they're colored. But water behaves differently. Instead of absorbing most visible light, it allows almost all of it to pass straight through. Your eyes receive light from whatever is behind the water. So your brain concludes, I'm looking through something. And that's why water appears transparent. But why doesn't water absorb visible light, when almost everything else does? For that, we need to zoom all the way down to the molecules themselves. Every tiny drop of water contains billions upon billions of molecules. Each one is incredibly small, far too small for your eyes to ever see. Inside those molecules, electrons can only absorb very specific amounts of energy. Visible light simply doesn't carry the right amount. It's almost like trying to unlock a door with the wrong key. The light arrives, the molecule checks it, and says, nope. So instead of keeping that light, the molecule lets it continue its journey. That's why most visible light passes almost untouched through water. But not every kind of light gets through. Water absorbs large amounts of infrared light. The kind of light we often experience as heat. This is one reason sunlight gradually loses energy as it travels deeper into oceans. If water lets visible light pass through, why does the ocean look blue? At first, many people think it's simply reflecting the sky. And while the sky does contribute a little, that's not the whole story. As sunlight travels through huge amounts of water, tiny amounts of red, orange, and yellow light are absorbed more than blue. After traveling long distances, mostly blue light remains. That's why deep oceans, massive lakes, and giant glaciers often appear beautifully blue. Ironically, the more water you have, the easier it becomes to see water's true color. The next time you pour yourself a glass of water, remember this: you're not looking at something invisible. You're looking at one of nature's most extraordinary materials. A substance whose molecules allow most visible light to pass almost unhindered. A property so ordinary that billions of people never question it. Yet without that transparency, life underwater would look completely different. Plants couldn't receive sunlight the same way. Animals would struggle to see. Even our own world would feel unfamiliar. Sometimes, the greatest mysteries aren't hidden in distant galaxies. They're sitting quietly inside the glass on your table. Because the most ordinary things often have the most extraordinary stories.